Hey all, welcome back. In today's session, we are going to talk about a very important topic in SystemVerilog, which is randomization. Okay, so among the various advanced features in SystemVerilog that we are looking, one of the important concept is oops, which I have already explained it, and I link that in the description box. I have created a separate playlist for that so that you can easily see all the videos at one place. That is why. So for this is the one of the important concept which is not present in Verilog and which was introduced in System Verilog. So I link that in the description box. You can go there and check it out. The second important concept is randomization. Okay, I don't say that this is not present in Verilog because if you are familiar with Verilog, you know that this randomization is present in Verilog also. In Verilog, you will be using the keywords like $random and $urandom in order to produce the various random values. Okay, but this randomization that you use in Verilog is not enough for the random, is not enough for System Verilog. Why? So the main reason for this is in System Verilog you will be having oops concept. That means everything is object based here. Okay, but in Verilog, since there is no oops, it was designed in order to generate the random values for variables but not for objects. Okay, that means since randomization need to be produced on objects, need to be done on objects. Okay, but since objects oriented programming was introduced in System Verilog, so this randomization that you see in System Verilog is more advanced than that of the Verilog concepts. Okay, because it is being performed on objects. Okay, class object randomization, that we call as class object randomization. So what does this randomization mean? Randomization is nothing but producing random values. So why do we need to produce random values? For example, if you are using some 32-bit values, okay, so that means 32-bit values, 32-bit variable means you will be having 2 power 32 possibilities. So 2 power 30, among the 2 power 32-bit possibilities, okay, by using this random, okay, randomization keyword or random method, all these 2 power 32 values will be given to will be provided, like it will be randomized and it will be among the 2 power 32 possibilities, every possibility will be displayed randomly. Okay, randomly means whatever it is. Okay, let me give you a small example for this. Okay, if you understand, basically, for example, when you are listening to music, okay, you will be having in music, you will be having a shuffle option, is it or not? So when you are shuffling, what happens? The random among your list of songs, you will be having the random song instead of you it in a continuous manner. Similarly, among these 2 power 32 possibilities, a random possibility will be displayed on the particular output case. Okay, so that is randomization basically. Okay, so how is this randomization used in System Verilog? Okay, so we are going to see that today. What is the need of randomization and why are we using this System Verilog randomization, and why are we taking this System Verilog randomization as a very important concept? Because this randomization is very important, because without this randomization concept you don't see any interview, you don't end any interview without this randomization concepts. So that is why this is very important. Okay, so let's not waste any more time. Let us see what is this randomization in System Verilog. So as I told you already, in Verilog you will be using $random and $urandom for randomizing the values. So what is the difference between $random and $urandom in Verilog and randomization in System Verilog? Let me give you a small thing here. Here, in case of $random and $urandom that you are using in Verilog, this is used to randomize only the variables. Okay, some any integer variables. For example, you are using int a. Okay, this int a can be randomized by using $random and $urandom keywords. Okay, But if it is much more than that, so what is that much more? Because since we are using class objects, okay, if you want to randomize the objects, if you want to randomize the arrays, okay, if you will be having lot more data types like enum, struct, okay, is it or not? In SystemVerilog, these were all introduced in SystemVerilog. If you want to randomize this, then this random and the random is not enough, because all these were introduced in SystemVerilog, and all these are not static in nature, they are dynamic in nature. So that is why, in order to produce randomization on these all things, you should be having the randomization concept in SystemVerilog. Okay, just like you will be using dollar random and dollar u random in Verilog, in SystemVerilog you will be using rand and randc keywords. Okay, so rand and randc are used for randomization in case of SystemVerilog. Okay, in case of Verilog you will be having dollar random and dollar u random, right? So now, as I already told you, okay, we'll be seeing about this what is dollar rand and dollar rand C also in the examples in the coming sessions. So this is about randomization. As I already told you, for which things that we are going to do randomization. Like you can do the randomization on any integral data types, like some int c, okay, or any singular variables, and you can do randomization on arrays. You can do randomization on array size. You can do randomization on object handles. So you can perform randomization on these various things, which is not possible in case of Verilog, right? So this is about the randomization. Now, okay, since we have seen about what is randomization, let us see now what is the need for randomization. Okay, why do we need randomization? Why do we need to produce random values? Okay, in order to know this, let us go some step like backward while we are writing the code for Verilog, right? So when we are writing the code for Verilog, you will be writing the RTL code and you will be writing the test bench. Okay, so in this RTL code, you will be writing the logic, and then in the test bench, you will be passing the values to the RTL code. How is it or not? Yes, you'll be passing the values. You have seen various codes like some adder, subtractor, everything. Is it or not? So for adder, you'll be having three inputs. So you will be passing the values manually, like c equal to 0, a equal to 1, b equal to 1. In this way, you will be passing. For example, if you are considering a 3-bit adder, so you will be having 2 power 3, so 8 possibility inputs. Is it or not? These inputs we will be calling it as stimulus. Stimulus or input, both are same. So you will be passing 8 input values, okay, to this RTL code or to your DUT, whatever it is. Okay, so this is what you will be basically doing for in Verilog. Okay, in Verilog, when you are writing the test bench code, you will be passing the values manually. Fine. Yes. Now the same thing if you are relating to the system Verilog. Okay, so as we already know, the system Verilog is mainly designed for verification purpose. Okay, in order to verify the complex test bin circuits. Okay, complex designs. In order to verify the complex designs, you will be using the system Verilog. That's why many of the verification engineers prefer system Verilog and UVM rather than Verilog for verification purpose. So in system Verilog, okay, when you want to pass the values, this is not as easy as we do in Verilog. Why? Because we are not going to verify basic things like adder, subtractor and all. We are going to even though we are doing this adder and subtractor, we are not doing it for 3-bit or 4-bit or like that. Okay, we are going for complex designs. So for example, when you are going to design when you are going to verify some 32-bit ALU, okay, so this was the thing that you need to verify. Okay, so this is the complex design. Why? Because 32-bit ALU means it will be producing 2 power 32 scenarios. So what is this scenario? Scenarios is nothing but 2 power 32 number of inputs need to be generated to my DUT. Okay, that means I need to send 2 power 32 number of inputs to my DUT in order to check my 32-bit ALU. No, not. Why? Because here, since we are checking a 3-bit adder, we are sending 8 inputs. Similarly, if when we want to verify 32-bit value, you need to send 2 power 32 number of inputs to your DUT. Is it or not? So, is it manually possible just by doing how we have done for full adder? Is it manually possible to do so? No, because even though we need to write this 2 power 32 number of possible values, firstly it is not possible. Even though it is possible, the code will be become very lengthy. Even though the code is very lengthy also, we can't always say that nothing is repeated. That means no input is repeated, and we have covered all the 2 power 32 possibilities. We didn't miss any scenario, we didn't miss any possibility of this. We can't be sure in that way. Is it or not? So in order to avoid all these things for the verification engineer, in order to avoid all this trouble for the verification engineer, we have introduced this randomization concept. Okay, so in this randomization, what it will be happening means, or this randomization will be taking this 2 power 32 scenarios, and it will be randomly providing inputs. It will be randomly giving the inputs to the DUT and covering all the 2 power 32 scenarios. Okay, will be it was designed for that. Okay, it was designed to provide random values to the DUT. Okay, without missing any corner cases, without missing any possible input values. So that is the need of randomization in order to verify the complex design. So this is not just a complex design. We are having much more complex designs. Okay, but this is why this was randomization concept was introduced in order to provide the random values to the DUT in the complex designs. Okay, hope you got an idea on why do we need this DUT. Okay, so this was not possible in SystemVerilog, because in SystemVerilog, since you don't have this randomization concept, so in order to provide random values to the test bench, you need to do it on your own. Okay, like you need to do it manually. You need to send all the stimulus to the DUT manually in case of Verilog, but that is not the case in SystemVerilog. Okay, in SystemVerilog, by with the help of OOPS concepts and randomization, you can do this. The system will be doing this without manually interference of all the passing of values and all everything. Okay, so this is about the randomization. This is the need of randomization. So by doing this randomization, it since it can generate stimulus easily, so then we it is not it is even though it is not possible for manually to write this, by using this randomization it can generate stimulus very easily. And also all the cases it will be covering. Okay, all the corner cases which manually may be missing in sometimes also, you can say that by using randomization it will be covering all the corner cases and everything. And because of this, the code length will be reduced, and also the maintenance time, like while we are running the code also, since it will be generating it automatically without any reference by the manual thing, so the generation and maintenance everything will be going on smoothly, right? So this is about the need of randomization. Now coming to the advantages of randomization. So as I told you, since it will be done all everything will be done automatically, it is very easy to find the hidden bugs. Okay, because as I told you, random combinations, since it is generated automatically, the random combinations will be generating automatically. So if there is any such random combination which we can't think of, but it is generated by the system, then it can find the bugs easily by using that. And also by using constraint based randomization also. This is very important. What is this constraint based randomization means? Randomization, for example, let us take the same example that we have discussed. 2 power 32 possibilities means very vast, is it or not? So, but among these 2 power 32-bit random possibilities, there may be some cases where you don't need to check all the possibilities. Okay, where you need to check only some possibilities. So, in such cases, if we are not limiting this 2 power 32 possibilities to the way we want, then it may take a lot of runtime, and the space and memory and the runtime, everything will be on wastage. So, in order to avoid this, also we are having a concept called constraints in SystemVerilog. So, constraint based randomization means, as I already told you, if you don't want all the possibilities to be checked, but only some amount of possibilities to be checked, then what happens? You will be limiting the constraint to that possibilities. That means, for example, if among these 2 power 32-bit possibilities, if you want only some 250 possibilities to be checked, then what happens? You can limit the randomization to only these 250 possibilities by using the constraints. Okay, we'll be discussing about these constraints also. Don't worry about that. Randomization and constraints go in together, and this is very important. Constraints, without constraints and without randomization, you don't see any interview without these two concepts. Okay, it provides flexibility to have random values based on user defined probability. Okay, that means based on by using constraint based on my probability, based on my possibility, you will be having generating the random values. Okay, system verilog randomization provides disability flexibility to disable randomization. Why is it? Because okay, in verilog you don't have this option, like you do when you are doing a randomization, then you are doing on it and there is no way to avoid it. But in case of randomization, even though you are doing randomization on certain objects and you don't want certain objects to be randomized, okay, then what you can do, you can disable that randomization in that particular object, on that particular object, or in that particular function by using the disable randomization technique. Okay, you'll be seeing all this with an examples, don't worry about that. But there is this option in system verilog. You can disable randomization as well as you can disable the constraints also. Even though you are putting the limitation, you can just take off that limitation also by using disable constraints. Okay, similarly you can disable the randomization also. So by using this randomization, it saves time and effort. Okay, instead of writing a very long and test scenarios for each and every test scenario, just by using the randomization keywords like rand and rancy, you can easily perform randomization on that particular objects or variables or anything. Okay, so this is about the advantages of randomization. So, as we already discussed, so these are the two things, RAND and RANC concepts. Okay, so we'll be discussing about this RAND and RANC in the upcoming class. So, that is all for today. If you like this video, please do like, share, and comment if you are having any doubts on this particular concept. And also, if you are new to this channel, consider subscribing my channel and hit on the notification bell also. Thank you all.